Hi Nana. We were learning the question banks related to study of gas laws. Okay. Today we will learn question bank 5, starting with question number 7. So seventh question, it is a numerical problem related question. So we will look into that problem once. So, the volume of a certain gas was found to be 11.2 decimeter cube. Okay, that means there was a certain gas. There was certain gas and its volume. So there was certain gas and its volume was how much? Its volume is 11.2 decimeter cube, it seems. Okay, so here the volume is volume of that gas is 11.2 decimeter cube. Okay, when the pressure was 1.5 atmosphere. So now the pressure of this one, suppose if I here just simply I've kept a piston. Okay, right. So now this gas whose volume is 11.2 decimeter cube. So now this gas is under the pressure of what? It is under the pressure of 1.5 atmosphere. So this gas is under the pressure of what? 1.5 atmosphere. Now the thing is, if the pressure is increased by 30%, so that means if I push this piston inside, what happens? All the molecules, so that means the pressures, so these molecules, I mean this gas, it is suffered, this gas will suffer due to increasing in the pressure on them. So now how much pressure is increased on this gas? So the pressure, suppose if P1 is the initial pressure and V1 is the initial volume of this gas. Now here as pressure is increased, so now the new pressure will be P2. Let us assume it is P2. So P2 is nothing but final pressure or else new pressure, and the P2 value, how much it is, how much will be the new pressure? So if the pressure is increased by 30%, that means actually the pressure was 1.5 atmosphere. So the new pressure is nothing but, so if you add 30%, if 30% of old pressure, okay, if you add what? If you add 30% of P1. Okay, so P2 is nothing but P1 plus 30% of P1. So together, that means because here the pressure is increased. So this pressure is increased by how much? By 30% of initial pressure. So total thing will be what? The final pressure. So if you add these two things, we'll get final pressure. So final pressure is nothing but, it is 30% more than initial pressure. So how to represent 30% more than initial pressure? Simply if you take initial pressure as P1, then if you add 30% of P1 so to this initial pressure, then that whole thing will be equal to final pressure. So that means what is the 30% of P1? So 1.5. If 1.5 is treated as, see here, 30%. What is the meaning of 30%? For 100, there will be increase of 30. If it is 100, there will be increase of 30. If it is 1.5, so there will be increase of how much? So that is nothing but 30% of P1. So here, so upon cross multiplication, so x will be equal to what? 1.5 into 30 by 100. So here 15 threes it will become 45 by 100. That means it is around 0.45. So that means 30% of P1. 30% of P1. So what is X? X is nothing but 30% of P1 is equal to X, which is equal to 0.45. So therefore P2 will be what? P1 plus 30% of P1. So 30% of P1 is how much? 0.45. And P1 is how much? 1.5. So 1.5 plus 0.45. So altogether it will be 1.95 atmosphere. It will be how much? 1.95 atmosphere. So the final pressure will be 1.95 atmosphere. Okay, the final pressure will be 1.95 atmosphere. So initial pressure is 1.5 atmosphere and initial volume is 11.2 decimeter cube. So if I increase the pressure, on this gas by 30%, so now the new pressure will be 1.95 atmosphere. So when pressure is increased, what happened to the volume? Volume will decrease automatically. Volume will decrease because according to Boyle's law, volume is inversely proportional to pressure. Whenever pressure is increased, volume should compulsorily decrease when the temperature is constant. When temperature is constant and amount of substance, mass means amount of substance. So here amount of substance is not changed. All the substance, all the gas has come together. All the gas molecules have come together, but there is no loss of gas or else there is no additional amount of gas. Okay, so and even the temperature is also not changed. If I increase the pressure on it, so all the molecules will come closer, but here the temperature is not changed. So temperature is constant and mass of the gas or else amount of the gas is constant. So under these two conditions, the volume of the gas will be inversely proportional to pressure. So that means when pressure is increased, here pressure is increased from 1.5 to 1.95. So automatically volume should decrease. So by how much the volume will be decreased, or else what will be the new volume of the gas? So how to calculate the new volume of the gas? Always remember that the product of pressure and volume, okay, under initial conditions will be exactly equal to the product of pressure and volume under final conditions. Okay, the product of pressure and volume is always constant. So that means how much the product of pressure P1 V1 will be, the same thing will be the product of P2 and V2 will be. Okay, so that means what is the product of P1 and V1? So P1 is given as 1.5 into V1 is given as 11.2. So it should be equal to P2 and V2. So what is P2? P2 is 1.95. And V2. So what is the new volume? So we have to calculate the new volume. So new volume is V2. The final volume or else new volume is V2. So therefore V2 will be calculated as like this, 1.5 into 11.2 by 1.95. Okay, so here upon calculation finally we will get this value 8.615, okay, decimeter cube. That means the new volume is 8.615 decimeter cube. See, remember that as the pressure is increased from 1.5 to 1.95, volume should automatically decrease. So here volume is decreased from 11.2 to 8.615. So which one is greater? Initial volume is greater than final volume because initial pressure is less than final pressure. So automatically initial volume will be greater than final volume. Okay, right. So this is about the seventh question. So how to calculate the new volume? So new volume can be calculated by using this equation. So this equation is said to be Boyle's law equation. So with the help of Boyle's law equation, we can find the new volume. Okay. So here, what is the new pressure? New pressure, it is obtained when we add the increase in pressure. So to the initial pressure, if you add the increase in pressure, then you will that total or that sum will give the new pressure. Okay, right. Next question, eighth question. What is eighth question? Eighth question is also a problem based question, numerical problem based question. Okay, so we will look into that. Eighth question, question number 8. The volume of a certain gas was found. The volume of a certain gas was found. The volume of a certain gas was found 560 centimeter cube. Okay, the volume of a certain gas was found 560 centimeter cube when pressure was 600 millimeter. Okay, so here the question is the volume of certain gas was found to be. So here if I take a certain amount of gas in a container, okay, now the volume of this gas, how much it is according to this question? So the volume of a certain gas was found to be 560 centimeter cube. So here the volume, so the volume of the gas is how much? 560 centimeter cube volume is present. Okay, a gas of whose volume 560 centimeter cube is present and its pressure was 600 millimeters of mercury. Okay, so now this gas was under which pressure? So this is the piston and this gas is under the pressure of how much? 600 millimeters. So what should we understand? So here if it is given as 600 millimeters, so we have to understand it as 600 millimeters of mercury. Okay, right. So here in the question it is given simply as 600 millimeters, but we have to understand it as 600 millimeters of mercury pressure. Okay, so now a certain gas is present whose volume is 560 centimeter cube and whose pressure is 600 millimeters of mercury. Okay, now if the pressure decreases by 40%, if the pressure decreases by 40%, so that means there is a decrease in pressure. How to decrease the pressure? How to decrease the pressure? If you take out this piston to certain height, what happens? The pressure inside the gas automatically will decreases. So if that means we are releasing certain pressure, that means here the pressure, now the gas is under certain pressure. If you take out this piston to certain height, what happens? So the gas molecules will become free and they will increase their volume because that gas is under low pressure. Okay, that means here the pressure is decreased. If the pressure is decreased by 40%, find new volume of gas. Okay, find new volume of gas. How to find new volume of gas? Okay, see here the conditions are the gas is present whose volume is 560 centimeter cube and whose pressure is 600 millimeters of mercury. That means that gas is under this much pressure. Now the pressure is decreased. If the pressure is decreased by 40%, so that means let us assume the initial volume as V1, initial pressure as P1 and final pressure as P2. Here the final pressure, how this final pressure is obtained? By decreasing the pressure by 40%. That means from initial pressure, if you remove 40% of the initial pressure. Okay, if you remove or else if you subtract 40% of initial pressure from the initial pressure, okay, then we will get the final pressure. So what is the initial pressure? Initial pressure is 600. 40% of 600, how much? So 40% of 600 means means 40 by 100 into 600. Okay, so how much it will be? 6 4 is 24. It will be 240. So that means we have to reduce or else we have to subtract 240 millimeters of mercury from 600 millimeters of mercury. We have to remove 240 millimeters of mercury from, because we have to remove 40% of pressure, because 40% of pressure is decreased from the initial pressure. So that means, so what will be left over? It will be around, it will be 360 millimeters of mercury. So the new pressure will be how much? The new pressure will be 360 millimeters of mercury. Then find the new volume of the gas. New volume of the gas. So what is the new volume? New volume, let us assume new volume as V2, final pressure, final volume. So we have to calculate what is the new volume. So in order to find the new volume of the gas, when initial pressure, initial volume and final pressure was known, okay, all these were known. So how to calculate the final volume? So in order to find the final volume of the gas, we have to take the help of Boyle's law equation. What is Boyle's law equation? P1 V1 is equal to P2 V2. So what is P1? 600 into what is V1? 560. 560 is equal to what is P2? P2 is 360. And what is V2? V2 we don't know. Let us assume it as V2 only. And now V2 can be calculated like this. So upon multiplying 600 with 560 and it is divided by 360, so 0 0 cancels. Okay, so here finally if you calculate this, we will get the value of 933.3 centimeter cube. So this is the new volume. The new volume of the gas V2, it is nothing but 933.3 centimeter cube. Okay, see, always remember that here the pressure is decreased by 40%. So that means initial pressure was 600 and final pressure was 360. That means pressure is decreased. When pressure is decreased, when there is a decrease in the pressure, compulsorily there should be increase in the volume. So the volume is increased from 560 to 933. Okay, so the volume will be compulsorily increased. Whenever the pressure is decreased, automatically the volume of the gas increases. Okay, so like this, eighth question can be calculated. Okay, now we will look into the ninth question. What is ninth question? Again, there is one more numerical problem. Ninth question. A vessel of capacity how much capacity? 6 decimeter cube. 6 decimeter cube. See, 1 decimeter cube is equal to 1 liter, remember. So 6 decimeter cube means 6 liters. Okay, so a vessel of capacity 6 decimeter cube contains nitrogen gas. Contain what? Nitrogen gas. Nitrogen gas. So, see here, I have a vessel, okay, whose capacity is 6 decimeter cube, or else 6 decimeter cube is nothing but 6 liters, 6 liters capacity vessel I have, and this vessel, it is filled with what? It is filled with nitrogen gas. Now this how much amount of nitrogen I have now? So now I have nitrogen 6 liters, which is filled in 6 liter vessel. Okay, now, and here nitrogen gas at a pressure of how much? At a pressure of 152 centimeters of mercury. See how much pressure is present inside this one. So volume is 6 decimeter cube, and the pressure is how much? Pressure is 152 centimeters of mercury. So this much of pressure is present in the gas, or else this much pressure. Now the gas is under this much pressure, nitrogen gas. Now, okay, see, if this vessel is connected, if this vessel is connected to another evacuated vessel. What is the meaning of evacuated vessel? Evacuated vessel means empty vessel. Okay, so now this vessel is connected to another evacuated vessel of 3 decimeter cube capacity. Okay, of 3 decimeter cube capacity. That means here this vessel, what is the capacity of this vessel? 6 decimeter cube. Now this vessel, it is connected to another vessel whose capacity is 3 decimeter cube. Okay, this vessel is connected to another empty vessel. So evacuated vessel means empty vessel. Okay, so now there is a connection. There is a connection made to this smaller vessel whose capacity is 3 decimeter cube, and the large vessel capacity is 6 decimeter cube. So when it is connected, what happens? So here the nitrogen gas which is present, it will slowly flow into this one. The nitrogen gas will flow into this one, and this smaller vessel also will be filled with nitrogen gas. See, here what is happened to the volume? Volume is increased. Initial volume is 6 decimeter cube. Now the volume occupied by this nitrogen gas, it was increased. So the new volume of this nitrogen gas is 6 plus 3. It is equal to how much? It is 9 decimeter cube. Before that, this nitrogen gas, it was occupying only 6 decimeter cube volume. But when it is connected to another vessel of 3 decimeter cube capacity, so now this nitrogen gas will flow into this vessel also. As it is connected, so the nitrogen gas will flow into this vessel. Now the nitrogen gas is occupying how much volume? Now the nitrogen gas is occupying 6 plus 3, 9 decimeter cube of volume. So the new volume is how much? 9 decimeter cube. So due to this, what happened? So here the pressure inside this larger vessel, when it is connected to the smaller vessel, what happened? The pressure will decrease. Automatically the pressure will decrease. So the new pressure, let us assume it has P2. We don't know what is that pressure. So here we have to find what should we find? What will be the pressure of nitrogen in both vessels? What will be the pressure of nitrogen in in both vessels. In both vessels. So here, so both vessels, what is the volume of nitrogen in both vessels? It is 9 decimeter cube. And what is the pressure of nitrogen in both the vessels? So we don't know. So let us assume it as P2. So we have to calculate this one. So in order to calculate this one, so here these are the initial conditions. These are the initial conditions P1 and V1. Now when a new when another container is added to this one, okay, another container or else another vessel is connected to this one, what happened? The volume is increased because the nitrogen it is occupying this much volume. That means 9 decimeter cube volume. So due to this, what happened? There will be decrease in pressure. So here a new pressure is now the nitrogen gas is under a new pressure. So new pressure, what is its new what is the new pressure value? So we don't know. So simply assume it as P2. Okay, so new volume is V2 and new pressure will be P2. So how to find the pressure of nitrogen in both vessels? So pressure of nitrogen in both vessels is nothing but P2, new pressure. New pressure is nothing but pressure of, because volume is nothing but V2 is nothing but volume of nitrogen in both vessels. Hence pressure P2 is nothing but pressure of nitrogen in both vessels. Okay, so if you consider P1 and V1 as the initial conditions, then P2 and V2 will be the final conditions. Okay, so according by applying Boyle's law equation, so P1 V1 will be equal to what? P2 V2. So here we have to find what? P2. Okay, final pressure. Okay, final pressure in both the containers, in both the vessels. So here P2 will be equal to how much? P1 V1 by V2. So what is P1? P1 is 152. What is V1? 6. And what is V2? V2 is nothing but 9. Okay, so we will get final pressure P2. That final pressure is nothing but the pressure of nitrogen in both the vessels. So upon calculating this one, so finally we will get it as 101.33 centimeters of mercury. Okay, so like this, the pressure of the gas in both the vessels can be calculated with the help of Boyle's law equation. Right? Next, 10th question. Next question is 10th question. What is 10th question? Tenth question, it is having some sub questions. Okay, 4 sub questions it is having. So we will learn those sub questions. So first sub question is define Kelvin 0. Okay, define Kelvin 0 and Kelvin scale of temperature. Define Kelvin 0 and Kelvin scale also, and Kelvin scale of temperature. Kelvin 0 and Kelvin scale of temperature. What is Kelvin 0? See, Kelvin 0 is the temperature. Actually, this temperature, it is only theoretically it is possible. Only theoretically. Because this no one can reach to this temperature. Kelvin 0 is the lowest temperature, very lowest temperature, and we cannot achieve this temperature experimentally or practically. We cannot get this temperature. So only during calculations only we will get this temperature, but in reality we cannot get this temperature. Okay, So that means simply we can calculate, we can tell it as a calculated temperature, or else simply we can call it as a theoretical temperature. And at this Kelvin 0, so what happens? All the molecules, all the molecules, okay, gas have zero kinetic energy. All the molecules of gas have zero kinetic energy. Zero kinetic energy. What is the meaning of zero kinetic energy? That means molecules does not move at all. Whenever kinetic energy is zero, that means the molecule does not move at all. They even stop vibrating also. There is no vibration also. No molecule will vibrate, or else no molecule will move. Okay, so such condition is said to be zero kinetic energy. Okay, so when molecules have zero kinetic energy, they does not move. They stop moving. They stop vibrating. Okay, so that temperature where the molecules of gas have zero kinetic energy, so that temperature is called as Kelvin 0, and it is not possible in reality. It is not possible. Hence, it is only a theoretical temperature. Okay, and its value 0 Kelvin value will be equal to minus 273 degrees centigrade. Okay, minus 273 degrees centigrade. Okay, it is okay, the temperature. So this temperature, the temperature on degree centigrade will be minus 273. Okay, so at minus 273 degrees centigrade, so the molecule have zero kinetic energy. That means they stop moving, or else they stop vibrating, and and this temperature is said to be 0 Kelvin. Okay, right. Next, what is Kelvin scale of temperature? Kelvin scale of temperature. Scale means measurement. So here, suppose if there is a thermometer whose lowest temperature, okay, whose lowest temperature is 0 Kelvin. Whose lowest temperature, its temperature starts with 0 Kelvin. Okay, the temperature scale which starts with 0 Kelvin is said to be Kelvin scale. The temperature scale which starts with 0 Kelvin, or else the lowest temperature, the temperature scale which is having 0 Kelvin as the lowest temperature, okay, is called as Kelvin scale. So the lowest temperature on Kelvin scale will be how much? It will be 0, or else minus 273 degree centigrade. Okay, so generally we won't use degree centigrade while expressing the Kelvin scale. Okay, so but its value will be minus 273. Okay, see here, what is Kelvin scale? Kelvin scale is nothing but it's a measurement of is a scale of measurement of temperature, and whose lowest value is nothing but 0 Kelvin. Okay, so its lowest temperature value will be 0 Kelvin, or else simply the scale which starts with 0 Kelvin is said to be Kelvin scale of temperature. Okay, here Kelvin scale, how to calculate the Kelvin temperature on Kelvin scale? See, temperature on Kelvin scale is equal to temperature on Kelvin scale is equal to temperature on Kelvin x Kelvin is equal to, sorry, temperature on Kelvin scale will be equal to what? Will be equal to 273 plus temperature on Celsius scale. Okay, if you add 273 to temperature on Celsius scale, we will get what? Temperature on Kelvin scale, or else simply K is equal to 273 plus C. So like this we can define Kelvin scale, or Kelvin scale of temperature. It is also called as absolute scale of temperature. Kelvin scale of temperature, it is also called as absolute scale of temperature. Absolute scale of temperature. Okay, so this temperature scale, it starts from 0 Kelvin. That means the lowest temperature on this scale will be 0 Kelvin, right? So this 10th question, it is having 4 sub questions. We have covered one sub question in this video. We will cover the other sub questions in the next video. Okay, Nana. Bye.